We're making cake. The cake is a lie. We're not making cake. It's math class. But we're discussing the math of cake. So look at your handout that you hopefully grabbed from back there. Laverne is having a birthday. I've not heard anyone called Laverne in a long time. But there was a famous show way back in the day, like even before I was a kid, called Laverne and Shirley. I'd be curious if you guys, like, if anyone had even heard of that show. It's old enough. But Laverne wants her birthday cake to be made into an L. It's her favorite letter because, you know, we're all just a little bit narcissistic. So Laverne's cake is going to look like this. What?
Forgot to clip the binder.
Well, the binder clips are a lie too sometimes. So Laverne's cake is going to look like this. We are going to have a cookie crust. Oh, by the way, sorry that you're going to end up hungry probably, at least if you're anything like me, where if you watch a show with food or talk about food, you're like, I want food. We're going to have cookie crust, chocolate mousse, and a whipped cream topping. I might even torch it a little bit to get a little bit of that, kind of like s'mores.
Okay,
what?
stop.
Can you smell the like toasted marshmallow?
Yes, I can,
Like, just trick your olfactory into... Alright, so, the first thing we need to figure out is what is the area of the base of the cake. And like we talked about with our prism work, base doesn't have to mean bottom, but here with Laverne's cake, is the base the bottom?
Yeah.
Yes. So the base is that L shape. And we talked yesterday, I think I told you guys the word orthogonal. I think somebody in here maybe figured it out. But orthogonal, like in chess, the rook moves orthogonally. It moves up, down, or left, right. When we talk orthogonal with like 3D shapes, we're talking about what's it look like from the top? What's it look like from the right, or from the front, or from the back? Like, it's all the different like square views of something. It means not diagonal, right? So here is not an orthogonal view. That's a diagonal view of the cake. Here is an orthogonal shot from the top. So that tells you all the dimensions that are necessary to figure out your big B. Start by figuring out your big B for the cake here. Figure out the area of that L. That's what we're doing. Figure out the area of that L. Break it up however you want, or solve it like however you... There are many ways to solve this. I can think of 3 right now. One could involve subtraction. Ooh, I bet many of you hadn't thought about the subtraction technique here. No, I'm just curious about the nutrition facts on these things. Like, this is what I normally look at for, is like how much sodium is in things, because that goes with blood pressure. That's 12. If you drink 8 of these, which that would obviously be bad for multiple reasons, but that'd be all the sodium you're supposed to have all day long. This isn't that bad. I was curious. Like, just now that's the one thing you do want to watch. I mean, your kids, you don't really care that much, but the saturated fats are the bad ones. Trans fats are better. So yeah, you just watch out for the saturated fats. What? It's food label math.
She just... I whispered to him, I thought this was math.
It is. It's all math.
That's fair.
All right. So we know that we could break this up into multiple rectangles. And, like, you know, more power to you. If that's the route you took, you could have broken this up like here and had that part and that part. You could have broken this up right here and had that part and that part. Or you could, as we talked about with, I think, last night's homework. Anyone want to explain what I mean by drawing that? Carter?
Basically, you just find the area of the little square, like that you just drew.
Careful. Square?
Well,
Just say polygon.
Rectangle.
Rectangle. The rectangle that you just drew in,
Yeah, because it's definitely not a square,
Which-
right?
looking a little less like a rectangle, but
Yeah, okay, you can't trust what things look like. On Halloween, Mr. Allen looked like a firefighter. You can't trust what things look like.
you want to find the area of that, and
Okay.
then find the area of like.
Did you find the area of this?
No, I did not.
Can some? What's 22 times 10? No. Get your fingers off your calculators. 22 times 10.
220?
220. 22 times 2.
44.
So together,
264.
264. Okay, keep talking.
Alright, and then you want to multiply 36
fine. Do that in a calculator. Fine. Well, I know we can, but like it will just take a moment.
864.
Okay, then what do we do, Carter?
Then you subtract the little rectangle that you drew in because it's not real and
It's not real.
The rectangle
It's
is
a
a lie.
lie.
The rectangle is a
And
lie.
you get 600.
you do get 600.
Did we all get 600?
I got
600 what?
Centimeters.
Centimeters squared.
Careful. If this is our big B, we're doing base area right now.
So
That would be centimeters squared. Because we are mainly answering just part A. What is the area of the cake in the pan? Now, if I was doing this, I would just make a rectangle cake, cut out that rectangle section, and I would just eat that for myself. And then give Laverne. But hey. Alright, so now Laverne needs to know the quantity of cookies we're going to buy. And guys, legit, like, this is how, like, I know you're like, I could just buy plenty, and then I'll have leftover cookies. I get it. But if you're, like, running a business, and you're trying to keep your costs down, or you want to try to match things up and not just have a bunch of stuff left over all the time, because that's a waste of money. So I need you to calculate the volume of the cookie part. You done yet? Because you should be. Why do I think that you only needed like 2 seconds to do that problem, Eva?
Because it's times 1, and like anything times 1 is the same number.
It's times 1! If we're just talking about the cookies, because she wants the volume of the cookies, so now our big B, our base area, right, we're going to do 600 times 1, but now our answer is 600
centimeters cubed.
centimeters cubed. Now, questions how we got where we got. Kira, I need you to take your art home at some point. I keep randomly thinking about it, and like it just, I'm worried. Or I'm gonna hang it on the wall. But you yelled at me when I said I was gonna hang it up, and you said you would take it home. So take it home where it's going up on the wall. All right, solve C on your own. You guys can read. I'm tired of talking. How many cookies do we need? How many cookies? Oh, Harrison's already there. How do we figure this out? How many cookies do we need? I thought I got out your cards already. Alright, this feels silly to ask, but do you guys know if Portal has like a phone app? I really want to play Portal again, but I don't have an Xbox.
I don't think it does.
Does it have a computer version? Is it on Steam?
It's on Steam. I think it's on Steam.
It is on Steam? Okay.
Yeah, I think it's on Steam.
I've never done anything on Steam, but I want to play
Steam is
Portal,
also-
so I might go get it.
I would
on
also recommend No Man's Sky.
If I end up on Steam, then I'll come back to you and say, what was that recommendation? Will, what can we do here to figure out how many cookies we need?
You could divide
Yeah, because if each cookie is going to provide us with... Now, double check that your labels are agreeing with each other, because sometimes I'll mess with you and one package is using one type of label and another package is another. But since they're using the same labels, Will says we can just take 600, divide it by our 5. What's 60 divided by 5? 12, and then put the 0 on, right? You don't have to reach for a calculator all the time. Look for how can I make this math easier in my head. So 120 cookies. And then if we can figure out how many cookies are in every package, we know how many packages to buy. Anyone want to guess like how many Oreos come in a package? Probably 30 or 40.
Yeah.
Like I mean, there's like the 3 rows of them, right? Or
Yeah.
whatever.
36.
Well, how many like Chips Ahoy do you think come in a package?
A little bit.
Chips Ahoy is definitely not as many.
Yeah. I was going to say the package is bigger, but then the cookies are also bigger. So.
Let's calculate the moose. Let's calculate the moose. No, different kind of moose. So if the moose is going to be 7 centimeters thick, and I think all this is on your paper, I just kind of condensed it. I should have honestly just put your paper up on the screen. So if the moose is 7 centimeters thick, then Arnya, how are we going to do the math for volume of moose? Yeah, we're just going to take our big B, right, that base area, and times it by 7. So our big B was 600. So I'm color coding. Guys, what's 6 times 7?
42.
Then put the zeros on. 4,200 what? Centimeters squared.
Cube.
Cubed. So I repeated whatever somebody said before. I was like, wait, no, that's wrong. Hoping you guys would catch it. Volume, cubed, always. Right? Volume is always cubed. Questions? Go ahead and do the whipped cream. That should be a mental thing. Like, come on, what's 600 times 1.5? 900, right? Centimeters squared again. Who copied the second time? See me after class, I owe you. Because I did it twice. Like, come on. The first time, like, I'll blame you that I was repeating what you guys said, but the fact that I did it again, I appreciate the catch. It means you're paying attention. Alright, so then I forget what they ask us. I try to memorize these lessons, but it's been a while. Oh, yeah. So if she has made, because guys, making your own whipped cream, which if you didn't realize, whipped cream is cream that has been whipped. Yeah, there are certain things that we just say and never think about. Yeah, if you take cream and you whip it enough, it becomes whipped cream. So if Laverne has made 1,200 cubic centimeters of whipped cream, is it enough? Well, how much whipped cream did we just calculate that we needed? 900, right? So Laverne is good, right? You have too much. Well, or
You just eat it.
or you could just make it higher, right? If it's like the top layer. So I agree with the math that we set up. We quote unquote have two, but okay. So how much do we have? How much did it say Laverne had? 1,200, right? 1,200. We want 900. Can you tell me how tall that top layer would turn into if I used 1,200 instead of 900? Eva, how are we going to do it?
2 centimeters, because technically, if you think about it, like the 900 was originally 600, and what is 1,200 divided by 600 or whatever the math? You get 2, right?
Since we know Big B is 600, that is worth 1 centimeter tall, right? Because Eva's saying, well, if the base area is 600, we go 1 times 1 is just 600. So if we use 1,200, this 1.5 would now become 2. Questions on how Eva figured that out? Some good, like, working with numbers and putting them together and things like that. I forget if I actually had more planned with it. Oh yeah. So real quick, because you kind of know how many people you're going to be able to give cake to. Did you know there's a way to have infinite cake? This is a math problem. We'll come back to it maybe. Because I can tell by your excitement that you're all so interested in the infinite cake problem.
Eat it.
But if one serving is 285 centimeters cubed, how many people can eat this cake? I want you to talk with your partner because we don't quite, like, we haven't necessarily done everything we need to be able to solve this, but you have all the information you need. Well, first off, let's decide, are we going to use all of the whipped topping she had or just the cake they showed us?
Just the cake.
Okay, just the cake they showed us. So, Kira, what would we need to do first in order to be able to answer a problem like this? Of like, well, if everyone has this much, what do we need to figure out first? The starting, so like what do you mean by starting amount? Yeah, the total volume of the cake. So we had 900, 4,200, and 600. Anyone get a total of our whole cake?
5,700.
5,700, right? 5,700. So that's our total cake volume. Why do I keep going too far? All right, 5,700. And remember, guys, if we're doing the math, if we're working with the numbers, you don't have to include labels. You can if you want. Final answers need labels. All right, so 5,700 divided by every person eating 285. Man, I hope Laverne has a lot of friends. How many people can eat this cake? I heard one confident number. I'd like a second one that agrees.
The one that he said.
And what would our label on this be?
Centimeters
People. Or servings, or whatever you want to say.
20.
So that does not need, obviously, like squared or cubed or anything, because
Cubed.
it's literally just calculated like, how many servings of cake, how many plates can we make?
What would that do?
Questions? It's cake, it's delicious. What do you mean, what would it do?
I mean, what would happen to the people if, like, you cubed them? What would they?
So, reminder. I mean,
People.
somebody said if their New Year's wish to be able to run fast enough that if they run through a chain link fence, they would just turn into cubes. So, I mean, is that a cubic person? Chain link fence are the kinds that are all the squares, like the diagonal, the metal fences. They said they want to run fast enough, and then it was posted on the math page. Guys, I'm a nerd, in case you haven't figured this out in the past 5 months that we've known each other. So one of the pages I follow online is like a do the math sort of page, like how fast would a human have to run to when they hit a chain link fence be cut into pieces.
Very fast.
It's kind of like sadistic math sometimes, but it's interesting.
What is the answer?
Yeah.
I didn't go into. I think it was like there's too many variables. What's your bone density? How strong is the fence? Yada yada.
Gotta go fast.
That's how nerdy the people on the page are. It's like, well, if you ran fast enough to do that, the fence would actually break because your bones are stronger than the fence. Because your bones are 3 times as strong as concrete.
Yes.
Fun fact.
Rocket.
All right. Reminder: prisms are not just boxes. Reminder: prisms are not just boxes. So, for example, it wasn't this homework, but you will very soon start to see prisms that are like a pentagon base, or like, so here, for volume, I know, we can do length times width times height. It's a box, you guys know that.
Prism.
But reminder that any prism, you can do big B, which is base area, times height, which needs to be the distance between them. So here, height could be any of these, because it depends what you call your base. But if you have something like a hexagonal prism, this cares what your base is. It would be the what? The hexagon, right? Because it's connected by rectangles. Now, on your home, I think it's tomorrow's homework, or maybe it's next week's, but closure's Friday, so I look at a lot of stuff at once, especially over break. Soon, we will give you math problems where I give you big B. Like, I give you a hexagonal prism, and I say, hey, big B is 240. Figure out the volume. All you would need to do is take your big B, multiply it by your height. Right? So, I'm not going to ask you to figure out the area of a hexagon. There is a formula. It's really just 2 trapezoids, right? You guys can figure it out. You're smart. But right now, what we're practicing is finding that volume, finding that surface area. You have the rest of this time to work on your homework, because I know, like, I gave you 2 yesterday, so I wanted to try to get through the lesson quickly today. You have the rest of the time until lunch to work on whatever you need to practice. I would encourage you to work with each other. Emery, feel better. By the way, don't listen. Pick an animal. Pick a color.
Emerald green.
Emerald green. Elephants.
Everybody was looking at you.